And we're live. Good morning, 601. You know, you can say good morning. We don't bite.
Good morning. Good morning.
Good morning.
Good morning.
All right, awesome.
Miss Canelo,
Yes.
I clicked on 602 Zoom link and I'm here. It's just giving you FYI.
Wait, what?
I clicked on 602 Zoom link and I'm here. I thought that 601 was last period every day.
602 is last period every day. 601 right now.
Well, I'm in the last period. I don't know if you, we'll talk later.
Okay. All right. So this is class 601. Everyone's in class 601 in this spot, correct? Okay. Today we're going to talk about the least common multiple and the greatest common factor. We're going to review by putting them together now. So instead of having them separate, now you're going to have problems and you have to figure out when to use GCF and when to use LCM. So before we get started, we're going to show you a quick little tutorial that was recorded. So if you haven't watched it, now's the time. So let me go hit share my.
Did you speak about iReady?
Oh no, I forgot about that. You want to do that?
Yeah, sure. Guys, so tomorrow you guys will be taking the iReady exam. And you're going to be doing that with your homeroom teacher. I don't know if they spoke about it, but pretty much you have to be online with your cameras on for 3 hours. That's the only thing you're responsible for the entire day. The only way you can leave your camera is by actually emailing your teacher at the time and telling them, hey, I need to use the restroom. Wait for them to confirm yes or no, and then you go about your day. Does that make sense to everyone? Just a thumbs up real quick to make sure that you guys heard that. Anaya, did you hear that? I don't see your thumb. So I'm assuming thumbs up, thumbs up, thumbs up. Emily, did you hear that? Emily? Yes, good question, Andrew. Yes, you do need your info, but you're going to be getting that tomorrow as well through your homeroom teacher. Any questions on that? I need you guys to do your very best on that. That iReady exam pretty much allows us to make sure that we know exactly where you're at. That way we can help you the best we can.
Are we allowed to use calculators? So this test.
Our math test is next week. You're doing English tomorrow.
So yeah, English is tomorrow. We'll talk about calculators when we get closer next week about how that works and what that looks like, okay?
Other than that, we can get started though. Sorry for taking like 3 minutes.
No, don't worry. It happens.
If more questions, just write it down in the chat and I'll be sure to answer it.
Right. Let me just pull up our Google Classroom. Oh, sorry guys. Let me just pull up our Google Classroom. Somehow it got deleted, but no problems, no worries. Miss Canella, Mr. R to the rescue. All right. Here we go. I'm going to go into 601 and I am going to go pull up the Google Classroom. Quick video to show you on LCM and GCF. So if you pay attention in this video, you will have no problem doing the work. So here it goes. Make sure you pay attention. And here you go, folks. Whoa, what happened to the video? Whoa. Hey, scholars. I just wanted to review the difference between the greatest common factor and the least common multiple because I noticed in class the other day, when we did GCF, we got it. And when we did LCM on Thursday, the other day, we got a little confused. So I wanted to clarify that up for you. So what I did is I created a quick little video for you. So I'm going to share my screen and I'm going to show you the difference. So, okay. When we are talking about finding the greatest common factor, which is on the left, where my cursor is, when you see the word greatest common factor, immediately you need to think of the words greatest, maximum, and most. And when you find the greatest common factor, what you're going to do is you're going to list all the factors of the number. So let's look at my friend 6 and 12. We want to find the greatest common factor of 6 and 12. So what we do is for 6, we want to list all the factors in order from least, which is the smallest, to greatest, which is the largest. So let's start with 6. We know that 1 times 6 is 6, and we know that 2 times 3 is 6. Those are the only factors that make up 6. Let's look at 12 in orange. Well, to get to 12, we know we have to multiply 1 times 12 is 12. We know that 2 times 6 equals 12, and 3 times 4 equals 12. Now that we listed the factors, we're going to look at what's in common in both. Both 6 and 12 have a 1, they both have a 2, they both have a 3, and they both have a 6. The greatest factor that is shared between 6 and 12 is 6. Therefore, that is the greatest common factor, or we call that the GCF. Let's look at now the least common multiple. When we see the word least common multiple, also known as LCM, we think the least or the smallest, and we're going to skip count, which means we write down all the multiples, which are the products. So let's look at finding the LCM of 5 and 10. So we're going to list all the multiples of 5, 5, 10, 15, 20. We're going to list all the multiples of 10, 10, 20, 30, 40. Now let's look at the purple and the pink, and we notice that both 5 and 10 have 20 in common. Therefore, that is the least common multiple, which is the smallest number. And I hope that this has helped you.
So guys, you just saw a video on finding the GCF and LCM. Recap real quickly. Greatest common factor, because you're going to get right to the work. When you see the word greatest, least, and maximum, or most, when you see the word greatest, maximum, and most, you find the GCF. For LCM, you're going to skip count. It's a multiple, right? LCM multiple, multiply. So LCM multiply, the numbers grow, they get bigger. You skip count. That should help you now when we do today's lesson. So here we go. Oh man, I got locked out of Google Classroom once again, and I don't know why. Here we go, 601. All right, let's get right to the work. Again, we're going to find the GCF and LCM of whole numbers and apply to real world situations. Mr. R, do you want to go over these two words and the diagrams with them? Wait, but you're muted. We can't hear you, Mr. R.
Okay, this computer is going crazy. It's doing stuff by itself. Okay. The greatest common factor shared between numbers. List factors and equal product in order to the least to greatest. Methods like rainbow and factor tree and listing methods is something to remember when you're doing the greatest common factor. The least common multiple shared between the numbers skip counting. So 4, 8, 12, 16, 2, 4, 6, 8 is another example. But if you scroll down, you guys will see a little objective of that and how we actually attack it. So the way it goes is this.
Oh, I'm sorry. I was thinking you were the host. So sorry, Mr. R.
The Venn diagram for GCF and LCM problem, keywords diagram. So the GCF those are the words, common words that you will see when you're doing greatest common factor on the left-hand side. On the right-hand side, you see least, which is least common multiple. And you see smallest, time, least, by, get. And the identical ones, which you also need to know, are the same number, same and similar and common. So the GCF, greatest common factor, biggest number that this is a factor of. So 12 and 9, the greatest common factor will be 3. How do you know? Because they all share the number 3, and it's the greatest one out of all. The LCM, on the other hand, is the smallest number that is the common multiple of 2 or more numbers. So 6 and 8 in this example is 1 times 6 is 6, 2 times 6 is 12, and so on. And the lowest common multiple is 24 in this example. Everybody see how we got that? Yes? Yes? No? Maybe? You guys are looking at me like I'm crazy. Thumbs up? Yes? Yes?
1, 2, 3 people, 4.
Okay. Sounds good. All right. So if you scroll more down, we're going to tackle the first problem, and I'll read it aloud. And Ms. Canelo, can you annotate? That sounds good?
Sure, you could do that one. Perfect. Let me just get Kami Editor up. All right, here we go. Give me 2 seconds, please. All right. Ooh, who's that? All right, we're back in.
All right, so the first one
Here
that we're going to be tackling is Eric is putting together snack bags for his classmates. He bought 18 bananas and 9 strawberries. Each snack bag will have the same number of bananas and strawberries. What is the greatest number of bananas and strawberries that Eric will have in each snack bag? Clearly, in this example, Ms. Canelo is helping us out. She highlighted 18 bananas. She also highlighted 9 strawberries. In this example, you also have the word same number, which is key to identify that they need to have the same number in between all. But you are also looking for the greatest number of bananas and strawberries to find out that is for GCF. For GCF for us, that's perfect. Now, when we restate the question is usually the last sentence of the problem. It says, what is the greatest number of bananas and strawberries that we'll have in each snack bag? Remember, they have to be an equal number too, right? So what's the greatest number for now? Good. After we do that, we start tackling the model. Now, the model in this example is GCF, which stands for greatest common factor. That means we will have to list the factors of 18 and 9. Why? Because those are the numbers of 18 bananas and 9 strawberries. So we're going to start off with 18. 18 factors of 18. Remember, this is just the listing method, right? We're not doing the skip, we're doing the listing. So 1 times 18, 2 times what? 2 is 18, 9. And then we have 3 times what? 6, right, guys? All of these numbers go into 18. The next one is number 9. 9 times 1 times 9, and then 3 times 3. Now we are going to be looking for the GCF, which equals, in this case, what numbers are in the same group. So we have 1 that is in common, and we have 3, and then we have 9, correct? So the greatest common factor in this case is 9. Are we done yet? No. Now is the part that we actually have to identify the same number, because they want the same number in each snack bag. So how do we do this? We could do this 2 ways. We could either divide the greatest common factor by the number of, in this case, or you could just look at the multiplication table. We chose greatest common factor. In this case, we have 2 times 9 equals 18. So we know that we need two stacks of bananas. That way it can equal what? 18, right? That's the greatest, the 9 for the greatest common factor. So 2 times 9 equals 18. So 2 snack bags of bananas. And then we will have to do the greatest common factor for the strawberries, which 9 times what? 1, right? So 1 snack bag of strawberries. Everybody see how we got that? Thumbs up if you've seen that we got that. Yeah, yeah. This is pretty much simple. There's another way to do this, and that's dividing, right? So if you take the 18 on the left, the 18 bananas, and you divide it by 9, you will still get 2 snack bags. See that? If you also take 9 strawberries divided by 9, you'll get 1 snack bag. Same numbers, right? 1, 2. But you need to make sure that you guys always answer the question. I hope that you guys understood this one, because the next one is LCM, and then the other one following that is all you. You guys got to do it on your own. Savvy?
So for this question,
That was me, right?
yeah, that was you who wrote that. But a store is holding a promotion of every 3rd customer receives a free keychain and every 4th customer receives a free magnet. Well, pretty simple. It's already annotated. Which customer will receive both a keychain and a magnet? So we already know that I'm going to put 3rd person or 3rd customer gets a keychain, right, to hold their keys. A 4th person, and these are real world examples, gets a magnet. Now, here's where it gets a little tricky. Which customer will receive both a keychain and a magnet? Pretty much that's asking you, when will they both get the same thing? So every means the least common multiple. So you're going to find the LCM, which is the least common multiple. That's what the question is asking you folks to do. So what do we have to solve for? Which or when will the customers both, I like to restate it this way, receive a key chain and, a magnet? Like which number customer will receive both, right? However you want to write it. You can either take what we wrote, my words, whatever words you want. We're going to model this, I just mentioned, because they're dealing with every, we're going to find the least common multiple. So we're going to find the LCM, least common multiple, of 3 and 4. And I think either I said it or Mr. R said it, somebody said it. We're going to do multiply. Least common multiple, we multiply.
Yeah.
It's kind of messages on the bed isn't done and everything's not put away.
What?
Again? Anaya, you said something?
Oh.
I didn't understand what you said. That's what I'm asking you to repeat yourself. It's fine. It's fine. Don't worry about it.
All right, we're gonna find the multiples of 3. When we find the multiples, the LCM, we skip count. So 3, 6, we're counting by 3s. Simple. 9, right? We're finding the multiples. We're finding the answer. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6 is 18, 3 times 7, 21, 3 times 8, oops, sorry, not M, is 24. Now I want to find the multiples of 4. Again, I'm going to skip count by 4s, folks. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24, and so on and so forth, yada, yada, yada. Now, we're going to find out what does both 3 and 4 have in common. I'm going to pull out my circle. Oh, somebody has their hand up. Give me 1 second.
Emily wants to answer. Go ahead, Emily.
Go ahead.
12.
Okay, what else, dear? What else? Emily, right?
Yeah.
And?
24.
Good. So tell me now, which customer receives both a keychain and a magnet?
The 12th customer.
So the LCM would be the 12th, would be 12. So the 12th, I love how you put the unit. The 12th customer, oops, I gotta learn how to spell. Oh my goodness, I can't even spell. Customer will, oh my goodness, will receive both. Oh my goodness. Maybe I shouldn't be the note taker today. All right, does everyone see how Emily got 12? Emily, it's 12 and not 24. Why?
Because we're finding the least common multiple. The least
Right.
common factor.
Excellent. The least common multiple, you're right the first time.
Oh.
I know, it all kind of sounds the same, right? Good job. Questions, comments, concerns? All right. You don't know who's up next because Mr. R and I have a list going. So you never know. Get ready.
The bad part is Emily already won, so it's Anaya's turn.
Whoa. All right. Number 3.
Anaya, help me out. What are we doing?
She hear you? Yeah.
What is the difference between finding the greatest common factor and the least common multiple of the numbers 4 and 12?
Talk to me. What are the factors of 4?
Factors of 4 are 1 times 4 equals 4 and 2 times 2 equals 4.
Now 12?
1 times 12 equals 12 and 2 times 6 equals 12.
There's one more.
And 3 times 4 equals 12.
Good. Now what is the greatest common factor?
The greatest common factor
Oh, so sorry. What do they share?
they both share 1 and they share 4 and 2.
What's the greatest?
The biggest is 4.
The next one, thank you, Anaya. Heaven. Now, multiples of 4.
4, 8, 12, 16,
4 times 5.
20,
One more.
24, me,
Good. Now 12, please. 12.
12, 2, 24,
Good. Next one.
32,
30.
36,
There you go. Now what's the LCM?
24,
You sure?
12,
Now why is it 12 and not 24?
because we're looking for the least common multiple.
Thank you, Heaven. Andrew, now answer this question. The difference between finding the GCF and the LCM is?
The difference is when you're finding the GCF, you're finding the greatest factor. not the greatest multiple or least common multiple. When you're looking for the LCM, you're looking for all the multiples of a certain number.
That was
Andrew, just a heads up. Anybody else that sounds like that, and I will let you know if you sound like that. You sound like you're yelling at us. Just lower down your microphone tab on the right hand side. If you don't know how to do that, look it up on YouTube really quick. It takes like 2 seconds. Okay, but I could definitely send the video if you guys want me to. Just say yes on the chat, and I will. Let's go on to the next one, Ms. Canova.
sure. Just give me another second. I'm almost there, Mr. R.
Unless you want me to split this one, you give me host and I'll do.
All right, here we go. All right. So the next contestant to read problem 4 is it, who's on our list? Tori, Mr. R?
No, Leah.
Leah. Hello, Leah. Number 4 is all you. Tell us what you got.
Okay. Miss balloons. Okay. Okay. So first one, we need 16 white balloons, and there's 3 factors actually. 32 balloons, 24 yellow balloons, and 16 white balloons. For the first part.
Hold on a second. Okay, 32 balloons, blue balloons, you said 24, what, yellow? Keep going. I don't think I caught the last part. How many white? All right, Leah, what is the question?
Yellow balloon.
Okay, so you have to find out the greatest number of arrangements that I can make, right? Leah, how are we modeling? How are we gonna model it?
What is the greatest number of
The greatest common factor of what number? What numbers? 32, what else?
by finding the greatest common factor?
Of what numbers? What numbers did we just write on the A column? What are those 3 numbers?
32, 24, and 16.
Thank you. That's what I was looking for. Now, give me, please, the factors of 32. I'll start.
32, 24, and 16.
All right, those are the numbers.
32,
now,
24, and 16.
Yes. Okay, now let's think of numbers that multiply to 32. We got 1 and 32, 2 and what? 2 times what?
Okay.
What was after 15?
32 times 1 is.
What comes after that? What comes after? What comes after 15? I forgot.
2 and 16.
Okay, great. We got 4 times 1.
16 is 30.
All right, awesome. And then we got, that's it, right? Let's do 24 just because we have 1 times 24. 2 and what, Leah?
4 times 8 is.
Okay,
4 times 8 is also 30.
You mean 4 times 6? Or do you mean 3 times 8? What do you mean? So 3 times 8, you said, I think is what you're trying to say, and 4 times 6, right? Let's move on to the next number.
4 times, what comes after the 4?
Okay. Let's move on now to the last number is 16, Leah. 1 times what?
16.
And 2 times what, Leah? 2 times what equals 16? 8, right? 4 times 4. I think it's a little hard to hear you. All right. Kayla, because it's a little hard to hear Leah, can you tell us what are the common numbers that are shared, please, Kayla?
So 1,
1.
I hear music. I hear something in the background.
2,
Uh-huh.
24.
1.
Sorry. I did the wrong math.
So, Leah,
Wow.
all right. Okay, Leah, we hear you, hon. All right, Kayla, help us out. You said, oh no, my screen, sorry. All right, we said we share 1, 2, and 4. What other,
I hear people still, Miss Canella.
do you know who it is? Because I don't know.
Well, we mute everyone and then we just unmute a certain people that talk.
I think it was Leah.
What?
Yes. Yes, Mr. R.
That's what I'm saying. Like we gotta mute everyone.
I did. Everyone's muted, right?
8.
I'm not really sure who it is. Who's talking right now?
And 4 times 4.
Okay, wait, who's talking right now? Hold on a minute.
Leah's screen going on and off. I
Okay,
think Leah.
okay. We heard some noise. Okay, so let's call on Kayla to finish us off. So Kayla, unmute yourself. Where are you, please? Okay, let me go back and share the screen. So Kayla, you started to say that 1, 2, and 4 were the common factors, but what is the actual GCF now?
the A,
Hmm?
the A,
Oh, yes, you're right. Hello, Miss Canella's got to wake up and smell the coffee because the students are right and she's wrong. Let's got to get you the right answer here. All right, 8. Now, did we finish the question or is there something else that we need to do?
there's something else.
Right, and so now we got to figure out what is the number of arrangements we can have. So let's look at this. If we have 8 blue balloons as the greatest common factor and we want to get to 32, we have 2 ways to do this. We can either divide the number of balloons by the GCF to get the missing factor, or we could use what we just did. So 8 times what's going to give me 32? So 8 times what equals 32?
I don't know, I'm solving it.
Okay. Can Andrew help you? Or Andrew? Hey, Andrew, can you help us out?
8 times 4.
8 times 4 equals 32.
Good. So we're going to write for Mr. R, is it packs or bags? What are we writing? I forgot.
Packs, I believe.
4 packs of blue.
Kayla, real quick. I want Kayla to do the 24 one.
Sure,
Right?
yeah.
Kayla, look at this real quick. We know that the greatest common factor is 8, correct? So now that you identified that, we need to know that it's going to be the common number. When we say the greatest common factor, it's common. It's the same thing that we need in order to have an equal distribution in between 32 blue balloons, 24 yellow balloons, and 16 white balloons. So the number that's common there is 8. So we know that if we have 4 packs on the top where it says 8 times 4 equals 32, that's how we got the 4 packs of blue balloons, correct? So I told you now to do 24. 8 times what number equals 24? It's right there in that last block. You see it?
8 times 3.
Good.
Yes. You need how many packs? Kayla,
Done.
say it again. I'm sorry, I didn't hear you.
How do I bring it?
Yeah, I don't know. You keep muting and then unmuting. So pretty much you just said 8 times 3, right? So that means 8 balloons come in the pack and 3. So we need 3 packs of yellow balloons in order to have 24 balloons in total. Does that make sense now? Same thing for the next one, right? 8 times a number is going to equal the number of packs that I can get 16 white balloons. So 8 times what? Kayla.
3.
No, to get 16. You said 3 before. That was yes, the 24. So 8 times what equals 16 now?
2.
2, good. So that means how many packs of balloons do we need? You just said it. You just said it. 2 packs of what?
2 packs of balloons.
Yes. And what color balloons? Let's see if you understand this part. What color is the balloons? Kayla, it's okay. I don't care about the background noise. Trust me. 2 packs of what?
We did blue,
You're
yellow.
muted. I see you talking. 2 packs of what? We did blue, we did yellow. It's on the left right there. Right in front of you on the ace slot, guys. That's why we do this. What color? I don't hear you.
White.
Good. Good. Yes. Yes. Thank you. Anybody got questions about that? I'm trying to make sure that the clarity is good, like you guys are understanding this. Andrew, I know you got it. I seen Kayla, she's trying to get it now. Heaven, you got it. Thumbs up if you're getting this, please. I'm going to check the gallery. Anaya, you got this? Anaya? Do you got this? Yes, yes. Thumbs up, thumbs up. Leah, do you got this? Heaven, do you got this? Thumbs up, guys. I need to see it. I need to see it. Thumbs up. You're going to be doing this on your own. Okay. I got your dozy with a thumbs up. Chris, I don't see nobody on Chris right now. Joel, you got this? Nah? You confused? It's okay. Tell me to repeat myself. It's okay. All right, Joel, you got this one coming up, okay? I don't hear you. You just said I. I see you said I, but I don't hear you because you're muted. All right.
Okay.
There we go. Now, Joel, keep it unmuted. Keep it unmuted. It's okay. Keep it unmuted. All right, so I'm gonna read this out loud and maybe Miss can look it right. McKaylin has 12 jars of grape jam, 16 jars of strawberry jam, and 24 jars of raspberry jam. She wants to place them into the greatest possible number of boxes so that each box has the same number of jars in each kind. How many boxes does she need? Okay, so we already know we labeled what? 12 grapes, 12 jars of grape, 16 strawberry,
Okay, GCF, greatest common factor.
24 raspberry. Now, Joel, what am I missing? Two words.
So hold on.
Hmm?
She wants to place the jam into the what?
The boxes.
Yeah, but into the what? It says it right there. It's highlighted in yellow.
Same number of jars.
Same number, and what else?
And of each kind of jam.
Yeah, but look, there's another one. It says it starts with a G.
Oh, hold on.
Is it greatest or least?
Greatest.
Good. Now, what are we trying to find? If it's greatest, what are we trying to find?
The factor.
Good.
Mm-hmm.
You guys see how he did that? He said greatest. Okay, he knows as well. Greatest common factor. Jackson, right? I think you're next, so pay attention. Find the GCF of what? The numbers of 12, 16, and 24 that represents the jars. I'm gonna do a time check. It's 11:36, Ms. Canella.
What?
It's 11:36.
I know. Okay, Mr. R. Who's your
All right.
next
So
contestant?
now, Jackson, Joel, pay attention. Jackson, you're gonna help me out with this, okay? We got a list of factors, okay? So I'm lagging, so I'm going to leave and come back. Don't even, I mean, you can, but it's gonna be a bit too late, Leah. So, ready, 12 grape. So Jackson, help me out. 1 times 12, right? What's the next one?
Two times what? How many groups of 2 are in 12?
Jackson. Jackson, I really don't hear you at all.
Chidozi has his hand up. Kareem had his hand up.
Irene, go. I mean, Chidozi, go.
6.
Good.
Good. Chris, I see Chris there now. Do the next one. 3 times what? Equals 12.
Guys,
Listen,
3 times
you
what?
just go for this. 3 times what?
Kareem has his hand up, Mr. R.
Irene.
3 times 4.
Good. Those of you that are not participating, I'm writing your names down. Like, we can't do this. Straight up. 16 strawberries. Hazel, help me out. We got 1 times 16. What's the next one? 2 times what?
1 times 16, 2 times 16,
Whoop,
2 times 8,
there you go. And one more.
4 times 4.
Good. Thank you. Jamie, the next one. 24. Raspberry. I see the hands. I respect Joel, Chidozi. I respect the people that already participated. Emily. Tori, you're next too, so pay attention. Then Heaven. So 2 times what? Jamie.
2 times 12.
Good. The next one is gonna be Tori. Tori, 3 times what?
Andrew's got his hand up, Mr. R, if they don't
I
know.
know, but I want to get. I don't hear you, Tori. You unmute yourself.
3 times 8.
Good. And Heaven, the last one. Heaven, 4 times what?
Evan, 4 times what is 24? Or how many groups of 4 do you need to get to 24? You know this.
Heaven, I don't hear you.
I know you know.
I need you to unmute yourself. How about Naya Miller? I know yet you could unmute yourself and talk. So Naya, help me out. 4 times what? I can't see you, so at least you can talk to get your credit for today.
4 times 6.
Good.
Oops.
And who was that just spoke? Heaven? That was Heaven?
That was
Oh, that was Anaya. Thank you. All right. So are we done yet, though? No, we got to locate the GCF. The GCF in this case is what? Anyone at this point, because we're running short on time.
somebody.
Unmute yourself and just yell out the answer. It's fine.
4.
4. Let's see. Yep, 4 it is, right? 4 as the GCF. Now, let me ask you guys something. Are we done yet?
No.
Good. I'm glad that you said no, because that's the correct answer. Now that we found the GCF, we have to find the multiples or the number of jars that go into each box. That way it can have an equal distribution in between each box. So we have 4 as a GCF. So 4, how many jars of grape jam do we need in each box?
4 times what is 12?
3.
Good. So we need 3 jars of grape jam. We need how many strawberry jams? How many strawberry jams do we need? Clearly GCF is 4. So 4 times what equals 16?
4.
4. Thank you, Emily.
4.
4 strawberry jams in each box. And now we need the number 24. So 4 times what equals 24?
6.
4 times 6.
Raspberry. Good, good. I appreciate those of you that are yelling it out. And since this is recorded, later on I'll go back and I'll make sure that I give you credit. Don't worry about it. This is great. Fantastic. Good. Now that we have to go straight down to the exit ticket, Ms. Canella.
Yes. And office hours, guys, are today at 2 to 3. So please
Yeah.
come.
Those of you that are getting confused and don't know what to do and don't know how to do it, please come see me at 2 o'clock. I'll be there. So I'll read this out really quickly. It says, read the problem and show all your work to receive full credit. Pencils are sold in the packs of 12 and erasers in packs of 9. Ms. Canella and Mr. Rudy want to make sure that to give each of the students a pencil and an eraser. What is the least number of packs they should buy so that there are none left over? Now, in this case, we already identified that we're doing what? LCM, least common multiple. You're going to have the same problem, guys, on a Google form later on today, and it's going to be there, and you got to do the work, though. It's going to tell you to do the work. You got to write it out, okay? real quick, those of you that are doing the LCM, 12 times 1 is 12, 12 times 2 is, and then so forth. Same thing with 9, right? And you got to keep going all the way through. I don't want the numbers now. I'm just giving you a heads up of how to do it. And then at the end, we're not done yet, because now you got to figure out how many you got to give each student, right? And then that's how you proceed with the problem. This is why I was telling you the whole time, please make sure you participated, and then you can get credit for today. Also, your exit tickets are going to be up there, and they're going to be worth even more credits. Any
And-
questions?
Wait, Mr. R, Joel had his hands up, and guys, don't forget, we're gonna have independent practice problems.
You unshare that way I can see everybody's face.
Yes, sir.
Thank you.